Guys, in the next video that we have, we are going to look at average atomic mass. So in the isotopes, I said that the periodic table has the most common isotope when you round it to a whole number. That's actually because it's called a weighted average atomic mass. A weighted average atomic mass is kind of like a way of finding your GPA. When they calculate your GPA, they actually go through and they figure out that if you have an A in a class, it's worth 4 points, just on a 4-point scale. Crosby has some classes that are worth 5 points like this one, and 6 points like your AP classes. However, we're going to go just to a straight 4-point scale. So if you have an A in a class, it's worth 4 points. If you have a B in a class, it's worth 3. A C is worth 2. A D, which we don't have here, is worth 1. And an F, you don't get any points into your GPA. So if you have like a GPA of 2.95 and you're applying to colleges, that's going to tell them that the majority of your grades on your report card are most likely B's. If you have an, I don't know, 4.0, that means that all of your classes you have all A's. If you apply to a school and you have a .625 GPA, that rounds to a 1, which means that the majority of your grades are probably a D. And so when they're looking at colleges, or if they're looking at like a employer or something like that, they're going to look at you and go, okay, well, this person did really well in school. They have probably what it takes to be successful at my job or at this college. If you have a lower GPA, that probably means that you're not willing to put in the work to get the better grades, and so you have to look at some other considerations there. Same thing with your isotopes. If you have a sample of 100 atoms of something and 95 of them have a mass of, let's say, like 16, and then the other 5 have a mass of 17, it's going to skew the average because so many of them have a mass of 16, it's going to skew it back to that 16. So a weighted average takes into consideration multiple factors. It's not just a regular average. So with your weighted average, we have a formula. And with the formula that we have here, it is written kind of down here at the bottom here. It says RA times the mass. And that's the mass number of that one isotope. And then we have the RA, which is relative abundance, times the mass of the other isotope. If you have 5 isotopes, you're going to do this 5 times. If you have 3 isotopes, you're going to do this 3 times. If you have 2 isotopes, you're only going to do this math twice. So what you're going to do to get your relative abundance, the RA that's written there, you're going to take your percentage that's given and you're going to turn it back into a decimal. So you're going to have to divide by 100. And then you're going to multiply that by the isotope number. So you're going to do that, like I said, for each of the different isotopes that are there. So if we have 2 isotopes, you're going to do this twice. Take your percentage, move it back to a decimal, and then multiply it by your mass. Add each one together. That's total is going to give you your average atomic mass. When you do this, you're going to need a unit. The unit on the periodic table is called an AMU. AMU is atomic mass unit. Atomic mass unit is actually a made-up unit by chemists, and it's based off of carbon. So they knew the mass of carbon. They know the mass of carbon is 12. So when they figured out the mass of a proton, which is the same as a neutron, they just took that mass of carbon and they divided it by 12. So when we wanted to find what is 1 AMU, it's 1/12 of the mass of carbon because there's 6 protons and there's 6 electrons in most carbon atoms. So it's the mass of 1 proton or 1 neutron for your AMU, atomic mass unit. So when you're doing the math, you're going to have to write out a unit. That unit that you're going to use is AMU. So I have these on a piece of paper again so I could write. I have 2 examples. It says that rubidium has 2 common isotopes. We have rubidium-85 and rubidium-87. The abundance of rubidium-85 is 72.2%. The abundance of rubidium-87 is 27.8%. What is the average atomic mass? So the majority of my sample, 72%, has a mass of 85. 28-ish% of my sample has a mass of 87. So we need to figure out that average atomic mass. The first step is we're going to take the 72.2 and we need to turn it back into a decimal. To do that, we're going to divide by 100. The easier method there is to move my decimal place 2 times that way in order to get rid of the percentage. So we have 0.722. We're going to multiply that by the mass number, which is 85. Plus, rubidium 87 is 27.8%. So we have 2 times, we move our decimal, so 0.278 times 87. Now, with a scientific calculator, you're going to plug it in exactly like I have it written here. You don't have to get an answer here and get an answer here and add them together. Use your calculator. It's going to make your life a lot easier. So I'm going to turn my calculator on. And when I do this, I'm going to open parentheses. 0.722 times 85. Close parentheses. Plus, open parentheses, 0.278 times 87. Close my parentheses. So I typed it into my calculator exactly like I have here, and I'm just going to hit enter or equals. In this class, we usually round to 2 decimal places. So this answer here, 85.56 AMU. When you have an atomic mass, average atomic mass, it always has 2 decimal places. So with this one, 85.56, 2 decimal places, just took that answer and rounded it. So I showed my work, I have the correct answer, and then I have my correct unit. Now another tip for these, when you're looking at this, the answer here is going to be closer to the highest percentage. So the higher percentage is 72.2%. My answer is really close to that 85. So that's the right answer. If I get an answer here and it says like, I don't know, 2.74, 2.74 is way different than 85, so I would need to do my calculation again. So always check to make sure that your answer is close to the highest percentage for my isotope. Now this one, it says titanium has 5 common isotopes. Titanium 46, titanium 47, 48, titanium 49, and titanium 50. What is the average atomic mass of titanium? So for this one, I'm going to do the same thing. Move my decimal place 2 places. 1, 2. So I have 0.08 times 46. So my mass number times the relative abundance. Plus, I'm just going to go down a line. It'll be a little bit easier for space. 1, 2, so 0.078 times 47 plus 1, 2, 0.734 times 48 plus, let's see, 1, 2, so 0.055 times 49 plus, this is the last one, 1, 2, 0.053 times 50. Again, I'm going to plug this all in my calculator exactly like I have it here. When I do that, it's just going to give me the answer, or you can go through each step and get an answer, but that's a lot of work. I wouldn't do that. So you're going to take 0.08 times 46 plus 0.078 times 47 plus 0.0734 times 48 plus 0.055 times 49 plus 0.053 times 50. Uh-oh, I made a mistake somewhere. Insert. I made a big mistake somewhere. Oh, I see what I did. Sorry. Delete. So I knew my answer for 16 was wrong because I was way different than this like 48 right here. So the answer that I got is 47.92 AMU. That answer is very close to this 48 that's here because 73% of my sample has a mass of 48. Therefore, I know that that's probably a right answer. Like I said, right away I knew that that answer was wrong, the 16.21, because it was so different than my isotopes. So my answer here, 47.92 AMU.